Loud whirring noises, enclosed spaces, complete stillness.
Magnetic resonance imaging, more commonly known as MRI, can produce the most accurate internal scans present today.
The first recorded person to observe magnetic properties was Thales of Miletus, a renowned Greek philosopher. He noticed that lodestone, or magnetite, could attract iron. Since animism colored the view of people in the time period, Thales believed the lodestone to be possessed by a soul, using it as an explanation for a phenomenon that wouldn't be fully understood until centuries later. Lodestone would continue to intrigue great minds, but its magnetic properties were eventually implemented by the Chinese to develop the first compass.
The Chinese compass consisted of a spoon or ladle made of lodestone that was placed on a bronze plate. The circular center of the compass represented the heavens, and the square plate symbolized the earth. The lodestone spoon was a representation of the Great Bear constellation, which contains the group of stars known as the Big Dipper. The handle of the spoon always pointed south due to the properties of the lodestone. Chinese characters spelling out the 8 main directions were carved into some of the bronze plates. The Chinese first used the compass for quasi-magical purposes, but the design was further developed in 8th century AD and became more common in navigational use.
Several radiologists, scientists, and physicists began researching magnets and their properties during the early 1900s. Wolfgang Pauli, for example, developed the idea of atomic spin. Otto Stern and I. Rabi demonstrated particles' ability to absorb radio frequency pulses. Felix Bloch and Edward Purcell both discovered nuclear magnetic resonance. This is the technological concept that would eventually be used to create the world's first MRI scanner. Several scientists began conducting a series of experiments with NMR, leading them one step closer to constructing an NMR scanner. The most notable contribution came from Raymond Vahan Damadian, an American medical practitioner from New York. Damadian published an abundant amount of research in Science magazine in 1971. In this writing, he discovered several innovative connections involving NMR, such as the link between cancer detection and nuclear magnetic resonance. For the next 5 years, he will utilize his theories on cell tissue's response to NMR to build, by hand, the first complete NMR body scanner. Finished in 1976, the revolutionary machine dubbed Indomitable was able to produce the first internal image of a human being. The visual relied on technology presented by Paul Lauterbur, who is credited with the initial development of body images derived from NMR signals. Damadian and Lauterbur would go on to receive several awards and accolades for their accomplishments, as many other scientists did, but there was an astounding amount of controversy over who would be awarded the 2003 Nobel Prize in Physiology or Medicine.
A particular Nobel Prize can be distributed to no more than 3 scientists in correlation to a specific discovery. The committee in charge of awarding the Nobel Prize were having a hard time deciding which scientists would receive it, since there were so many qualified for it. There was one underlying question: who contributed the most to magnetic resonance imaging over the years? Damadian and Lauterbur had different opinions on who did what, and in the end, Lauterbur received the 2003 Nobel Prize along with Peter Mansfield, and Damadian was left out.
Despite the controversy surrounding the contributions to the advancement of magnetic resonance imaging, MRI scanners continued to progress and quickly became essential to the medical industry.
These scanners were a revolutionary creation in terms of diagnostic testing. Previously, doctors and physicians couldn't diagnose patients with cancer and other conditions without relying on findings from exploratory surgery. Once MRI procedures came along, the need for those surgeries were basically expelled. Now, tomographic or internal images of the body could be easily obtained, allowing doctors to easily locate ailments like tumors and aneurysms, all through the use of radio frequency pulses emitted in the confines of a magnetic field. While a patient is scanned in the machine, the large-scale magnets align the water molecules or the hydrogen nuclei inside of those molecules that are located in the body. As the radio frequency pulse is administered, the nuclei absorb that energy and change position until the pulse expires. The resulting image is created from the signal transmitted from the. There is also a property known as relaxation time that is taken into account when acquiring tomographic images. represented with two values, T1 and T2, relaxation time is the length of time required for hydrogen atoms to emit signals after the RF pulse.
In comparison to other forms of radiology like CAT scans and X-rays, MRIs are generally much safer due to the lack of ionizing radiation. However, the magnets inside the apparatus are a great cause of concern. Some patients cannot be examined with MRI due to the presence of metal organs and molecules inside their bodies, such as pacemakers.
The room housing the technology must also be free of all metal objects. The highest risk associated with MRIs is the projectile effect, which can turn seemingly harmless metal objects, such as the oxygen tank in this video clip, into dangerous projectiles that have the potential to cause great damage if attracted at the right angle.
MRI technology has come a long way since the lodestone magnets of ancient times. Although the technology is less than a century old, it continues to save millions of lives today. One can only imagine the number of lives it can save as the technology continues to advance.